Forget the meerkats. This week, we compare the mongooses.
There's 9 tiny little pups peeping their heads out from underneath the building. And they're all ridiculously cute, really, aren't they?
Welcome to the Planet Earth podcast. I'm Richard Hollingham, and we'll be hearing from those mongooses shortly. This week I'm in Leeds, and if you know the city, you'll know exactly where I am, at the pedestrian crossing just outside the railway station. In the morning and evening, this pavement is packed with people trying to cross the road to and from work. It's the perfect place to stand if you study the behaviour of crowds, which is what Jolyon Faria from the University of Leeds does. Now, Jolyon, you've been watching people cross this particular junction from this particular point we're standing.
Yes, this is true. We're interested in if individuals are interacting socially with one another, specifically if individuals are following one another across the road.
What are you hoping to see then?
We're testing a theory that perhaps when an individual crosses the road, not only are they looking at how far away the traffic is from the crossing to determine if they cross the road, but also if they're actually following one another across the road as well. For instance, if one person crosses the road, is another person waiting at the crossing more likely to start to cross?
Why do a study like this? What's the end purpose?
I became interested in this because there's a cost-benefit going on here, similar to what we see in animals quite often, in that an individual gets to the crossing. They want to cross quickly, but they also want to cross with a low amount of risk. So they can either wait for the green pedestrian man, and cross then and wait for it, or they can cross the red pedestrian man and cross quickly. And I looked at the literature and I realised that there's not strong evidence for or against whether people follow one another across the road.
And looking at this junction here, they really do race round the cars and the buses, even a few lorries here. It's a one-way system. If you cross the road here and if you go against the green man, you are actually putting your life at risk, aren't you?
Certainly, yeah. I've just seen now 2 people in stilettos just tottering across, just missing the bus. And I actually looked at the braking distance of cars at about 30 miles per hour and people walking across the road, and I think it was at least 3 or 4 people in 100 who were crossing within these braking distance. So if the vehicle drive, for whatever reason, lost concentration, they may hit these people. This is important, and there's over 10,000 people are injured each year at pedestrian crossings in the UK. So this is an important behaviour to look at.
Well, Jolyon, we'll talk a little bit more later. Let's turn our attention, though, in the meantime, from human to animal behaviour and meet the mongooses. Banded mongooses are fascinating animals. They live in complex social groups and cooperate to find food and raise their young. And here's the strangest thing. The females in a group all give birth at the same time. Michael Cant from the University of Exeter has been studying mongooses in Uganda for more than 15 years. His studies are helping us get a better understanding of the evolution of cooperation. On his last trip to the field site, we asked him to take an audio recorder with him. So here's his audio diary.
Finally made it to Mwea, which is in Queen Elizabeth National Park in western Uganda. I'm back now looking out over Lake Edward from this peninsula. It's like a sort of heart-shaped peninsula, and it juts out into Lake Edward, and it's absolutely spectacular. Looking out across the lake to the Ruwenzori Mountains, and then just in the distance is the mountain range of Congo. The border's just about 20 kilometres from where I am now. So here we are at pack 11, which is a nice habituated pack. We can stand and walk with these guys. And this pack has given birth. How long ago did they give birth, Francis?
2 days ago.
So 2 days ago they give birth, which means that at the moment they'll have very small pups in the den, and each day they'll be leaving 1 or more babysitters at the den while the rest of the group goes out to forage. The idea here is to try and identify which individuals are out of the den so that we can then work out who the babysitters are. And I can see one of the babysitters outside the den, and we just heard this mewing noise of very young pups. And that kind of slight growling noise you heard there was a warning call by one of the babysitters, looking at me a little bit suspiciously It's 6:30 a.m. I'm here with Jennifer Sanderson, and we're going to collect some faeces. Nice thing to do first thing on a morning. So I guess we'll explain why when we get there. So shall we go, Jennifer?
Yeah, let's go.
Okay. So we're now sitting outside the den, and one of the individuals has just popped its head out and come out to have a look at us, and just delivered a nice fecal sample which Jenny's gone to get. And these are highly social animals. They live in large cooperative groups of around 20 individuals, and they exhibit this unusual breeding system. They're cooperative breeders, which means that adults help to raise offspring that are not their own. You get tremendous variation in the amount of effort that different individuals put into helping to raise the offspring. So one of the questions that Jenny's looking at is she's collecting fecal samples to try and measure the levels of different hormones that are circulating in these different animals, and to try correlate this with the differences in their contributions to helping the group, to their teamwork. So we're here now at this group, Pack 1B, that lives around the luxury safari lodge on Weir Peninsula, and these are the most habituated animals. And right now Solomon and Francis are just picking them up and putting them into bags. We're actually catching females that we're going to treat with a contraceptive, which just means that they fail to implant after mating, and we can switch them off for a single breeding attempt, and then after that they breed as normal afterwards. Sarah Hodge is in charge of this experiment. So Sarah, just tell me, which animals have you caught here?
So this group has 6 females of breeding age, and 4 of them are in the sort of older category. They're the more dominant females, and 2 of them are a little bit younger. And what we're doing in this experiment is we're giving a contraceptive injection to the younger females and stopping them breeding, so that we only have the 4 older females that will become pregnant and give birth. And what we predict will happen is that they'll be more successful when there are only 4 females breeding than when there are more females breeding.
So that's because of the correlational data. When we look at natural variation in the number of breeding females, we find that the reproductive success is greatest for individual females when there's 3, 4, 5 of them breeding. Is that right?
Yeah, so I think when too many females breed, then you get too many pups foraging in the group and there's too much competition, and the offspring of the older females will suffer because they'll be outcompeted for food. So what we're trying to do in this experiment is bring it down to what we think is the optimal number of breeding females. So what we'll do is compare this litter where there's only 4 females breeding, or 3 or 4 females breeding, to another litter where all of these females are bred.
So we're in the trapping office now. We've anaesthetised the first of these females that we're going to treat with contraceptive, and we've just given her a light anaesthetic. So Francis is now just cutting a little bit of fur from the rump of the female. So each of the females has an individual shaving mark, which we just clip a little bit of their hair, of their fur. With these very habituated ones, we can just clip their hair, and it's a very sort of subtle marking that we can recognise, but doesn't affect the animal at all. And now Francis is checking for ticks and fleas. We can get measures of body condition, look at their tooth wear, and really see how healthy they are. So that's that female's done now, and we just put her back in the cage with a little bit of water for when she wakes up. Cover the cage with a cloth, and within about 5 minutes she'll be looking sort of bright-eyed and bushy-tailed again. Oh, look at that. This is now Pack 1B's new den, which is under one of the lodge rooms, and we're just watching as... Have you counted them yet? I think there was 9 when I saw them a few days ago. There's 9 tiny little pups peeping their heads out from underneath the building, and they're all ridiculously cute, really, aren't they? The pups have just wandered out. This is the first time that I've seen them, And the first thing you notice really is that there's one particular pup that's about half the size of the others. And we do find in general that there's enormous variation in the size of pups when we first see them. And the reasons for this, we think, are that, 4 or 5 females gave birth in this breeding attempt. And even though they all give birth on the same day, they don't all mate on the same day. And in fact, the older females typically mate 4 or 5 days earlier than the younger females in the group. So this means that these younger females are giving birth prematurely relative to the older ones. And this, we think, is the cause of these quite substantial differences in the size of pups. So you might ask, why do these younger females synchronise birth to the same day as dominance when they're going to produce pups that are so obviously inferior in their competitive ability? And what our data tells us is that they're in a cruel bind, really. If they give birth too early, if they give birth before dominant females, then their pups are killed by infanticidal older females. But if they give birth after dominant females, then their pups do even worse. They're completely outcompeted by these older pups whose growth really takes off after they're born. The best of a bad job, really, is to give birth on exactly the same day. So the group have finally come out of the bush, and they've moved off. And the reason why I'm speaking so quietly is that David Janssen, who's doing his PhD on vocal communication in banded mongooses, he's at the moment got a microphone on a long boom that he's keeping very close to the head of an animal as it forages, as it searches for food, as it finds food and digs for food and so on. And he's finding that the contact calls that these individuals make, these small, short chucks that we think function to keep the group together as a cohesive whole, he finds that these contact calls, even though they sound identical to us, they're subtly different depending on what the activity is that the animal's doing. So, David, you're going to do a playback on this individual here.
This will probably work for the whole group because it's a recruitment call.
And here they come. So the animals are all streaming out of the bush and giving their own response calls. Great, well that was pretty conclusive.
Michael Cant from the University of Exeter with his audio diary from Uganda. We'll put a link to Michael's research on our host website, Planet Earth Online. We'll also post some pictures of banded mongooses and our location here in Leeds on our Facebook page. I have to say, it's not the prettiest location, a noisy traffic island outside the station. And I'm with Jolyon Faria, who's studying human behaviour and literally watching people cross the road, studying people cross the road. What did you find then from your study of observing people go across this busy junction?
What we were recording was the order that individuals cross the road and their position along the roadside. And the idea was that if the nearest neighbour of someone who was crossing, if they tended to cross before other individuals on the crossing, this would give us evidence that people were following one another across the road. And we compared observations I made with a video recorder of this crossing with a simulation I made in the lab. And if we found a mismatch between the two, this would provide evidence, strong evidence, that people were following one another across the road.
So people are taking their cues from others at the junction. Let's watch this couple over here, just about to cross the road. So something's going on, either consciously or subconsciously. They're watching the traffic. They've got half an eye really on the green man, but actually they're taking cues from each other.
Yeah, it's fascinating to watch because individuals are, in the main, in fact, everyone I've looked at, they look at the road, but there is this signature that individuals are following one another, and there is this little behaviour that I've noticed quite a lot, and I've analysed, where when one person starts to cross the road, other individuals make little steps forward, and this looks like it's most likely because individuals are wanting to follow, as well as keeping their eye on the traffic.
And how does this compare with animals? I mean, obviously you've not got a herd of wildebeest trying to cross the road outside the station here in Leeds, but they herd and they get cues, and as we heard about the mongooses, all sorts of complicated things going on in the social structure.
Oh, certainly, social behaviour is very common in the animal kingdom. When I talk about social information, it's individuals interacting with one another. And this scenario we have here is we liken it to maybe swallows on a line or penguins at an ice floe, where they're thinking, what would I like to do next, using what we call private information. And then they're also looking at one another and seeing what they're going to do, and they're trying to work out the optimal strategy based on these two sets of information. So yeah, this is a scenario that is certainly common in the animal kingdom as well.
You also notice that this is, I think, really intriguing, a difference between male and female behaviour at crossings.
Yeah, this was something that initially when I started the study, this was something that I hadn't really considered, but I had that many people ask me, is there a difference between men and women, that I looked back at my data and I found a signature in the data that showed that men were more likely to follow someone across the road than women. What I didn't find an overall tendency for men to cross the road sooner than women, so it didn't seem like it was to do with men being more likely to take risks. It just seemed that they were more likely to follow someone else across the road. So I can't really explain that, and that's definitely something that needs further work.
This is really interesting, because just as we've been talking, a gentleman's come up to us, and you actually got knocked over. You were eavesdropping on the.
You know what? This is the worst place in Leeds for me.
So you got knocked over on this crossing. But tell me how you were trying to cross the road, because you weren't crossing on a green man. You were actually watching someone else.
I was stood on the red area where everybody's supposed to stand, and I was on the telephone and I saw somebody's legs start walking. So I just followed them instinctively. Less than 2 seconds after that, I was hit by something very heavy. And came through the air a certain distance and landed over there, right where we are now.
You actually, looking at the crossing here, you flew through the air about 5 metres, didn't you?
Over the bin and landed about there, but rolled, obviously, because I had momentum, you see, so I rolled. This is where I landed, and about an 8-foot circle there.
And this was all because you were watching someone else, and you actually taking
on the phone, you see, so I didn't see the green man because there wasn't one. But somebody's trying to skip across, you see, and I just saw their feet move, so I kind of followed them.
Johnny, this is exactly the sorts of thing you've been researching.
Yes. This is. I was just looking at a sheet of data showing X amount of injuries at X amount of crossings. So I never expected to hear any first-hand account of it.
So, what's your name?
Sean Grimshaw.
So, Sean, thank you very much for sharing your experience. Do you now watch the Green Man when you're crossing the road?
Oh yeah, definitely.
Well, Julian, thank you very much. Fascinating research. For the latest news on the natural world, do visit Planet Earth online. For pictures, videos and the odd audio boo from the podcasts, you can also find us on Facebook, YouTube and Twitter. Let us have any feedback, and if you enjoy the Planet Earth podcast, please spread the word or write a review on iTunes or do both. I'm Richard Hollingham from the centre of Leeds. Thanks for listening, and do be careful when you cross the road.